A galaxy is going to collide with ours. Andromeda, the largest galaxy in our cosmic neighborhood, is approaching us at a speed of 248,000 miles per hour. The collision is unstoppable. The question is, what exactly will happen? Will it be like two balls colliding and bouncing off each other? Will they merge instantly? And what will happen to us? Will we be destroyed in the process? Interestingly, none of these things will happen. Let's start by introducing the main players. On a very dark night, you can see both galaxies in the sky without a telescope. On one side, we have the Milky Way, the galaxy we live in. On the other, we have this small smudge, the central part of Andromeda. Andromeda is actually a galactic behemoth with about 10 times more mass than the Milky Way. We see it so tiny because it's very far away, 2 million light-years from us. If the Andromedans could see what's happening on Earth, they'd see some primates doing funny things. In any case, Andromeda is approaching us. And the reason is the most natural thing in the world: gravity. In our little group of galaxies, Andromeda and the Milky Way are the largest. Mass attracts mass, and we have a collision in the making. The attraction is so strong that even the expansion of the universe can't separate the two galaxies, unlike with the others. Now, what will this process look like exactly? Well, although Andromeda is moving at an astonishing speed, it's actually a slowpoke compared to the 2 million light-years it has to travel. Its arrival will be a very slow process, slow on the scale of billions of years. That is, if we could see this approach unfold in real time, we'd see Earth's tectonic plates move at this speed. Very, very slow. Little by little, each millennium Andromeda will get slightly larger in our sky, and we'll be able to see its details more easily. After the first billion years, it will look like a bright disk in the sky, and initially we wouldn't have noticed anything. Now let's jump to 2 billion years from now. Andromeda has covered the distance between us and is passing by the Milky Way for the first time in history. Our night sky will be completely filled by Andromeda and its satellite galaxies, but this view will be temporary. Because Andromeda and the Milky Way have been accelerating towards each other for all these millions of years, thanks to gravity, at their point of meeting they will pass through each other at 1.5 million kilometers per h. Yes, they will pass through each other. Think of a galaxy as essentially a collection of stars, gas, dust, and dark matter held together by gravity. Despite the Milky Way having billions of stars, each one is separated from another by titanic distances. If the two galaxies were two armies charging at each other, each soldier would be separated from the next by about 30,000 kilometers, roughly 3 Earths. At the time of their encounter, the armies would collide, but in reality, the troops would keep charging and moving forward because they wouldn't meet anyone. There's a lot of empty space, so it's no wonder all these stars will just pass by each other. However, the large amounts of gas will be compressed and stirred during the collision, promoting the birth of a bunch of stars. Now, although it's very unlikely that any star will collide violently with another, the gravitational influence of the two galaxies will change the shape of the Milky Way. Our disk will stop being disk-like, forming a tidal tail with all the stars and gas most affected by Andromeda, like a deformed extension of our galaxy. As before, this will be a very slow process. In fact, Andromeda will remain overlapped with the Milky Way for a few million years. During this entire dance, Earth faces a risk. No, the chance of colliding head-on with another star is ridiculously small, but we could end up being displaced. In this crossing, we might become part of the tail and change our galactic neighborhood. According to some estimates, there's a 12% chance of this happening. There's even a 2.7% chance that the Sun will end up in Andromeda, and we will go with it when the collision ends. In the sky, we would see Andromeda getting huge, overlapping with the Milky Way before staying, and then seeing the Milky Way get smaller in the opposite direction. Either way, this could be risky. There are regions of our galaxy that are very active, full of dangers for a planet full of life like ours. Although it's also true that the solar system orbits the galaxy roughly every 200 million years, it might be inevitable. But the story doesn't end here. After the encounter, the galaxies will keep moving, being slowed down by each other's gravity. They're estimated to separate by almost 1 million light-years. They will stop and start moving toward each other again. 3 billion years from today, the second approach will occur, similar to the first. A point of light growing in size until we see its interior in full detail. And then it separates again, but not as quickly as before. They will move apart again, but only 170,000 light-years. The process is decaying. With each pass, the galaxies have lost energy. Due to gravitational interaction with particles, gas, and dark matter between the Milky Way and Andromeda, there's friction that dissipates energy, accelerating the merging process. This will be their last oscillation. In the next encounter, the two galaxies will merge into one. This will happen 5 billion years from now. After so many encounters, the supermassive black holes of both galaxies will start orbiting each other, generating gravitational waves. At the end of this process, they will release energy 1 billion times greater than what our sun emits in a whole year. A tremor in space-time, which won't have much impact on our planet. And basically, that's it. Andromeda and the Milky Way will no longer exist. There will be a new irregular-shaped galaxy in the cosmos. We present to you Milkamida. All of this is fascinating, but what about us? As you've seen, we shouldn't worry about this in our daily lives. It's like waiting for a mountain to change. In fact, I'd say it's even worse than watching a mountain change. Going back to the movement of tectonic plates, in the 2 billion years we have to wait until Andromeda's first pass, many places on Earth will have changed their location by tens of thousands of kilometers. In that time, a part of Earth could travel around the world 10 times without a problem. This reminds me of a more palpable problem: the age of our star. As it gets older, it becomes hotter. By the time all those thousands of years have passed, life on Earth as we know it may no longer be viable.